A very warm good morning to one and all present over here class. Welcome to the digital platform of APS. Now this is Pawan Kumar. Today I will discuss some proofs related to limits, continuity and differentiability questions. So this is a smart proof and our proof is related to limits, which is very helpful to solve the questions. So prove that question is prove that 1 plus 1 by n limit n tends to infinity 1 plus 1 by n to the power n is equal to e. So this is our proof. So first of all, you will see the solution. Since x plus a expansion power n, we know nc0 x to the power n into a to the power 0 plus nc1 x to the power n minus 1 a to the power 1 plus nc2 x to the power n minus 2 a to the power 2 up to dash dash ncn x to the power 0 a to the power n, and its preceding term is ncn minus 1 x to the power 1 into a to the power n minus 1. Now this is the expansion. Later x is equal to 1 and a is equal to 1 by n. So I will use this expression, this value in the given binomial. So 1 plus 1 by n power n, we can write nc0 1 to the power n into 1 by n to the power 0 plus nc1 1 to the power n minus 1 into 1 by n to the power 1 plus nc2 1 to the power n minus 2 into 1 by n to the power 2. Plus up to the last term is ncn 1 to the power 0 into 1 by n to the power n, and its preceding term is plus nc n minus 1 into 1 to the power 1 into 1 by n to the power n minus 1. So 1 plus 1 by n power n, we can write nc0 result is 1. So its result is 1. nc1, this is n into 1 upon n. Now second term is nc2 means factorial n upon n minus 2 factorial into 2 factorial into 1 upon n square plus factorial n upon n minus 3 factorial into 3 factorial into 1 upon n cube plus up to dash dash. And the last term is, that is infinity. So this is the expression, and now we have to put the limit. So what will get the result? See, this is 1 plus 1 plus, this is n minus 1 upon n minus 2 factorial will cancel out, whole upon factorial 2 into 1 upon n square, means 1 upon n square is here, plus n minus 1 n minus 2 whole upon factorial 3 with 1 upon n cube plus up to dash dash. Now we are going to put the limit. So before putting the limit, this is 1 and this one can be written as 1 upon factorial 1, and when you will take n common, so n square in bracket 1 minus 1 by n whole upon factorial 2 with 1 upon n square plus, this is n cube 1 minus 1 by n 1 minus 2 by n whole upon n cube into factorial 3 or whole upon factorial 3 into 1 upon n cube plus up to infinity. So now we have to operate the limit. Since limit is given, n tends to infinity, n tends to infinity. So operate the limit. N tends to infinity on both the sides. So result will be limit n tends to infinity 1 plus 1 by n power n. We can write 1 plus 1 upon factorial 1, and this n square is cancelled out, this n cube is cancelled out. So result will be plus 1 upon factorial 2 with limit n tends to infinity 1 minus 1 by n plus 1 upon factorial 3 limit n tends to infinity 1 minus 2 by n plus up to dash dash infinity. So now this is our result, and its result is limit n tends to infinity 1 plus 1 by n to the power n is equal to 1 plus 1 upon factorial 1 plus 1 upon factorial 2 plus 1 upon factorial 3 and similarly 1 upon factorial 4 up to infinity. So consider this is equation 1. This is equation 1. Now you know the formula of exponential since we know e to the power x is equal to 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3 up to infinity. Let x is equal to 1. This implies e to the power 1 1 plus 1 upon factorial 1 plus 1 upon factorial 2 plus up to infinity. This is the value of e. Now we can consider this is equation 2. So from equation 1 and 2, from equation 1 and 2, limit n tends to infinity, this is e. This is the formula. Now this is the formula. So in this formula, if I will consider, let x is equal to 1 by n. X is equal to 1 by n. This implies 1 by x is equal to, or 1 by x is equal to n, and 1 by n, this is n, so n tends to, or since n tends to infinity, this implies 1 by n will tend to 0 or 1 by x. 1 by x will tend to 0. So we can set another formula. This implies limit x tends to, or this is x we have considered 1 by n. So n we have considered x is equal to 1 by n. Then x is equal to, when we will consider 1 by n, or n is equal to when we will consider, let n, this is 1 by x, or this is same process. So 1 by x I can consider n. So what will be the result? Result will be limit n tends to infinity. This implies x tends to 0. 1 plus, this is 1 by n, result is x. 1 by n result is x. And now 1 by n result is x, and this is n. This will be 1 by x. And this result we can also write, that is E. So this is the formula. And we have to prove this part. So this one is completed. Now I will come to the next question. Or from this expression we can also find out the values of E and their range. See, and the value of E is lies between 2 to 3. So how we can prove it? See, since you know, and we already know 1 plus 1 by n, this result is always, you know, since 1 plus 1 by n power n, its result is, you know, 1 plus 1 upon factorial 1 and 1 plus 1 plus 1 upon factorial 2. This one you know, and in bracket 1 minus 1 by n. And similarly 1 upon factorial 3, this is 1 minus 1 by n and 1 minus 2 by n. This is the result. So factorial 3 and so on we can write. This is 2. This result is 2. And this result is more than 2. This result is more than 2. Now what we can say and what we can write? Consider this is equation 1. This is equation 1. Now we can write 1 plus 1 by n power n is equal to 1 plus, or this one we can write more than 1 plus 1 upon factorial 2. This is factorial 2, means we can write 2, and factorial 3 we can write 1 upon 2 square. This is more than, plus 1 upon factorial 2 cube, factorial 2 cube, plus up to n times. So result will be, it has n minus 1 factor, 1 upon 2 to the power, this one we can write n minus 1 factor. How? Because total number of term is n plus 1, so 2 term is left, 1 2, and from 1 by 2 to the power 1, 1 by 2 to the power 2, 1 by 2 to the power 3 up to 2n minus 2 to the power n minus 1 factors. So this one 2 2 up to n minus 1 factor we can write. Now it is clear the series are in GP. So 1 plus 1 by n, this result is 2, you know, and this result we can write 1 by 2 when I will take common, or directly we can solve it. Common ratio is R, that is 1 by 2. So A 1 minus 1 by 2 to the power n whole upon 1 minus 1 by 2. C. Now what will be the result? Result will be, this calculation will 2 and 2 by 2, 1 by 2, 1 by 2, 1 by 2 will cancel out. So after calculation what will be the result? What we can write? See, so this result will be 1 because of series starting from 1 plus 1 by 2 to the power 1. This is 1 by 2 to the power 0. So first term is 1. This will be 1. Now calculation will be 1 plus, this result is 2 in bracket 1 minus 1 upon 2 to the power n. See, now when you will multiply, so what you will get the result? So 1 by n less than, this is 1 plus 2 minus 2 to the power n minus 1. See, 2 to the power n minus 1. This is 1 upon 2 to the power n. So this will multiply. So what will be the result? 2 to the power minus n and 2 to the power minus n minus 1. So its result will be 1 upon 2 to the power n minus 1. This is 1 upon 2 to the power n minus 1. And now this result is 3 minus 1 upon 2 to the power n minus 1 for all small n belongs to natural number. So less than 3. We can write this is less than 3. Therefore, 1 plus 1 by n power n is more than 2 and less than 3. This implies now this is its value lying between 2 and 3. Now you can see